We learned that the area under the normal curve represents proportion and probability. So we're going to use the following example to practice that. In this example, it says that in a study of US veteran patients undergoing a first liver transplant, the ages in years of patients are approximately normally distributed. And normal curve is shown here, 54.3. As you can see, it's right in the middle, so it represents mean, right? So it means that most US veteran patients undergoing a first liver transplant are close to this age, 54.3. That's why we have the highest part of the normal curve over here. But then there are some patients that are older, and there are some patients that are younger, right? Though there are less of patients like that. And we want to interpret this area. Well, it says interpret the orange area. It's no longer orange. Let me make it orange. Actually, I have orange color. So now it's orange. So we want to interpret this orange area, which is noted to be 0.13. Remember that tall area on the normal curve is 1, but this orange area is 0.13. So we want to interpret it as probability, proportion, and percentile. So let's try that. So every time when we interpret that area as probability, we start with words like that. Probability that are randomly selected, and then we use words from the example. So in this case, it's going to be probability that a randomly selected US veteran patient undergoing a first liver transplant. What about that randomly selected patient? Well, since this number, 0.13, corresponds to the area that's to the left of 48. And then 48, what is 48? Well, 48 represents years. So 48, that's years. But then the fact that this area is lying to the left of 48, we're going to use word less. Less, or in the context of this problem, we can say younger. So one more time. Probability that a randomly selected US veteran patient undergoing a first liver transplant is under or younger of 48 years of age is, and then we have to state what probability is. Well, probability will be this, 0.13, which is the same as 13%. So we're going to write this down. So here's that sentence. Once again, we start with saying probability. That's what we need to use for part A. Probability that the randomly selected, that's going to be the beginning of the sentence every time. Then you have to state your population described in the problem. In this case, it's US veteran patient undergoing a first liver transplant. Then you want to state the specific condition, right? And it all comes from what kind of area we're looking at. So in this case, it's the area to the left of 48, which is years. So that's why I'm saying it's under or less or younger, right? I can use those words. Under 48 years of age is, and then I'm stating the area itself. It's 0.13, but this time, again, it's representing probability, which is same as 13%. I could also say it's a 30% chance that a randomly selected US veteran patient undergoing a first liver transplant is going to be under 48 years of age. And another way to interpret that, I'm not writing all that, but it's still good to, hear that. Another way I can interpret the probability itself, like what does it mean that probability is 0.13 or 13%? I can say the following. If we randomly select 100 US veteran patients undergoing a first liver transplant, that we can expect that approximately 13 of them are going to be under the age of 48. So now let's try to interpret that same area as proportion. So in this case, 0.13 represents proportion, or we can use 13%. And then sentences can be phrased slightly different, but they should all have the same kind of meaning. So in this case, in the case of proportion, we can start this way. We can say that 13% of, well, again, I'm describing the population, that 13% of US veteran patients undergoing a first liver transplant what about them? What is about 13% of them? Well, their age is below 48. So let's write this down. So I wrote 13% of US veteran patients undergoing the first liver transplant is under 48 years of age. And in this case, 13% represents proportion. Proportion, like that. Now, and the last question is to interpret that area, point 13, as percentile. So remember, percentile is the measure of position. So when we say percentile, we always connect that to one specific data value. Now, in this case, the data values are ages or years, right? Ages of US veteran patients undergoing a first liver transplant. So our data values are all along this number line. And it means that when we want to interpret this area as percentile, it's going to refer to this specific data value, 48 years of age. So first we need to be reminded that percentile corresponds to percentage of data values that are below or less than or equal the one that you're looking at. So when we're looking at 48 years, we can see that, and we already talked about that, 13% of patients are younger than that, right? So that means that 48 years is at 13th percentile. Let's write this down. So this is one of the ways to phrase the sentence. We can say, among US veteran patients undergoing a first liver transplant, the age of 48 years is in the 13th percentile. So if you read that question somewhere, then you would need to know that the meaning of that is that 13% of patients are less than or equal to 48 years in their age. So when you read this kind of sentence somewhere, then you would know that the meaning of that is that 13% of US veteran patients undergoing their first liver transplant are 48 years of age or younger. So that's the idea of the percentile.